Welcome to 5th grade Unit 6, Operations and Word Problems. This unit, you're not going to find a lot of new information in it. We're just going to be practicing some of the skills that we've done in the past. Putting together equations for word problems. Making sure we know in word problems what kind of math we maybe need to do to solve for the problem. So here we go. Have your note sheet ready and your notebook. The first one's variable. A variable is a letter or a symbol that represents a different number. Remember, equations can have more than one variable in it. Variable can represent an amount, and if we have a constant change, then it can give us our other value. So we'll see sometimes those two variables in an equation. Some new words that maybe you haven't heard before, but really should know what they mean. The first one's additive comparison, and the second one's multiplicative comparison. Both of them are just fancy terms to say that we're doing a comparison problem that's either using addition or it's using multiplication. So you can see here we have a comparison for additive comparison is a comparison in which one quantity is an amount greater or less than another. So if we have the example, Josh has 5 more goldfish than Tia, we can use J for Josh, T for Tia, and we can say that Tia plus 5 equals Josh, or Josh minus 5 equals Tia. And again, this shows that if we change the amount that Josh has, Tia's amount is going to change in an equal amount. The same thing goes with multiplicative comparison. For this, in which quantities of a number of times the size of a number, a multiplicative comparison can be represented. So Thomas picked 3 times as many apples as Katie. So we can do 3 times C equals T, or we can do T divided by 3 equals C. Notice we can also write it as 1/3 times T, because 1/3 and divided by 3 mean the same thing. Comparison problems. We've done comparison bars in the past, so again, this is not a new concept. Just one maybe that we need a little practice again. Maybe we have forgotten. Jenny scores 18 points in a basketball game. This is twice the number of points that Mia scores. So comparison bars, we have the big bar on top, the little bar on bottom, and the circle to represent change. So we have to look at this problem and think, which one has more? Jenny scored 18, so we know Jenny's amount in the basketball game. So that means Jenny's is, so sometimes if you replace the word this with the who they just talked about or the what they just talked about, you can understand the problem better. So Jenny's is twice the number of points that Mia scored. So we know that Jenny is on top, she's the big amount. Mia's on bottom, the small amount. We knew that Jenny had 18 points. And we knew that this was twice. So that would be a times 2 is our change. So we can write the equation now of J divided by 2 equals M. Or we could say 2M equals J. But to solve it, we're going to do our 18 divided by our change amount 2 to get Mia's amount M. And we find out that Mia scored 9 points. Now, this would be great if the question asked how many points did Mia score? Because we needed to find that information out in order to answer the true question here. The true question here says, how many points did they score all together? So make sure when you're solving a problem, you really are understanding what the different amounts mean as you solve them. So we're going to take Jenny's 18, and we're going to add now the 9 that we found out that Mia has. And we're going to find out that they both scored 27 points all together. So make sure you understand what each part of the problem is. The next thing we're going to talk about is situation and solution equations. Situation equation is how the problem is written. The variable will be within the problem. The solution equation then moves the variable to the end or the beginning on the other side of the equal sign in order to solve for that missing amount. So let's take a look at our example. The musicians in a marching band are arranged in equal rows. So we don't know the amount of rows right now. With 8 musicians in each row. So we have a keyword there, each, which tells us we're multiplying. Remember, when we have a variable, we can put our number next to variable, and that means to multiply. We don't need any math symbol between them. Well, equal, or altogether the band has 104 musicians. So this is our situation equation because the variable is contained within the equation. We now want to have a solution equation. The solution equation removes the r and it isolates it by itself. So if we had the total of 104, we had a part of 8 and a part of r, we know we have a total and a part, so we can use division, that inverse operation to multiplication, and we can divide our 8 to now equal the r. So now we isolated our r. Now we could actually solve this problem. If it's asking for a situation equation, the variable must be part of the equation. If we are finding the solution equation, then the variable is at the end or the answer portion of our equation. If we were to solve this out, we will get r equals 13 rows of musicians needed. But for the most part, I just wanted you to understand how to put together the equations. Here's some different ways to help you understand how to say some of the equations. So equations into words. If it's addition, sum of blank and blank, total of blank and blank. And we'd fill those blanks in with the known numbers of a problem or a variable. Subtraction, we might say blank decreased by blank. We might use the word minus or difference between. Multiplication might say multiply blank by blank. Blank times blank. The product of blank and blank. Remember, product means multiplication answer. Sum, addition answer. Difference, subtraction answer. And quotient of, that would be a division answer. So for division, divide blank by blank. The quotient of blank divided by blank. So those are all different ways we could say a problem. So now we're going to look at this problem below. Write a problem that could use the following equation. So this equation says 4 divided by a half equals C. So we want to write a word problem that could make sense to this. So since we have the variable C, I'm going to use cakes. If we have 4 cakes and we divide them in half, how much cake do we have left? Or how much cake pieces do we have? Well, if you had 4 cakes, 4 of them, and we divide them in half. How many pieces of cake do we now have? We have 8 pieces of cake. So that could stand for one of the problems we could have said for this equation. Rounding to estimate. When we want to solve a problem quickly, we want to use rounding to estimate our answers to come up with quick solutions. So the example they gave, 50 minus $19.12 equals N. Well, if $19.12 is rounded to 20, the amount of change is about 30, because 50 minus 20 equals 30. Let's take a look at our example. So if we wanted to estimate our problem, to get ready for her first semester of school, Jenna spends a total of $7.92. So if I take my $7.92 and I want to estimate it, I'm going to round it to the nearest whole dollar, and that would be $8. For 8 identical notebooks, what is the cost of each notebook? So we would do our $8 divided by our 8 notebooks, and we find out that each notebook is about $1. Now we can find our actual, and our estimate should make sense to our actual answer. So if we actually solve this out, we would want to divide our true number of 7.92, and we divide that by 8. 8 goes into 7 0 times. 8 goes into 79 9 times. 8 goes into 72 9 times. And we pull that decimal straight up, and we get an actual answer of 99 cents. So yes, our estimation was very close to our true answer. Order of operations are always an important thing to remember when you're working on an operations and word problem unit. Remember, always do parentheses first. What falls within the parentheses? Next, exponents. Then we do multiplication, division. Remember, we do those at the same time because they're equal partners, and we do them from left to right. So you might be doing division, then multiplication. And then we do addition, subtraction from left to right. And again, remember, they're equal partners, so it could be subtraction, then addition. It's time to fill out the bottom of the note sheet. Give it a try. Check your answers with the video and see how you did. Welcome back. Let's check our answers. If we wanted to write a word problem, now this is where you're going to have to just check your answers to see, did your answers or did your word problem make sense? I said a recipe calls for 1/3 cup of sugar. You want to make 4 times that amount. How much sugar do you need? And if we actually solve that, we would get 1 1/3 cups. The bottom one, how many sheets of paper were used when divided into thirds equals 1/6? And the answer here would be 1/2 sheets. Number 2, we're using rounding to prove our answer. So our estimation, the $5.70 is going to round to $6. The 8 will stay an 8. 6 times 8 is $48. Then we're going to solve out our actual problem to see if we have a reasonable answer. And so $5.70 times 8 gets us $45.60. So yes, we have a reasonable answer. Number 3, write the correct answer of Mary has 48 markers. Sam has 1/3 as many markers as Mary. So who has more? Mary has more markers than Sam. So this situation equation has, this one is written wrong. Let's fix that. All right, never mind. Our equations are correct. Sam divided by 1/3 equals 48, which is Mary's amount. Or Mary's 48 times 1/3 will equal Sam's amount. And so Sam has 16 markers. Write the correct answer. The 5th grade class at Lincoln Middle School collected a total of 462 cans for the food drive. Mr. Beck's class collected 120 cans. So we're going to take the 462 minus the 120 to find out how many cans the other 3 classes collected. And then we're going to take that amount and divide it by 3, since there were 3 classes that collected that amount. And they all collected the same amount of cans. So they collected 114 cans. We're going to look at all the different ways we could solve the problem that they have. 2 students each bought 2 pencils and an eraser. 3 students each bought a pen and 3 pencils. So A works because there are 13 pencils that were bought, 2 erasers bought, and 3 pens bought. So we would do 13 times the pencil amount, plus 2 times the eraser amount, 3 times the pen amount. Otherwise, we could have solved it based on how they said the problem. So we have 2 pencils and an eraser, and 2 kids bought that. And then a pencil and 3 pens, and 3 kids bought that. If in doubt, when it comes to equations, try them out. See if you would total up to the same amount. But make sure you're doing your math carefully. Rewatch the video if you need to. Otherwise, this unit's going to just take a lot of reading with attention to the details in the question, looking for any of those tricks, trying to think, do I need to solve something first before I can get to my final answer? Try the IXL skills plan. Watch or do any of the lessons in the Math Activity Center, and good luck.